So we're going to begin looking at statistics and start off with this thing called probability distributions. Probability distribution assigns numerical values to outcomes in some sample space. It's basically what we do, because once they're numbers, then we can do statistics on it. Now, the outcomes themselves might be numeric elements of the sample space. A numeric, so a roll of the dice, because you might get a 1 or a 2 or a 3. They're numbers. But of course, they might be categorical, where the actual elements themselves are not numbers. They might be things. Blood types. You get A positive, B negative, all that sort of stuff. Now, what is a random variable? We're going to be looking at random variables. A random variable is simply a function. The value of that function is all to do with the probability of the event happening. Random variables we usually denote with an uppercase letter, and then its value we represent with a lowercase letter. Random variables are continuous if all the possible values are spread over an interval and there's no breaks in that interval. Or they might be discrete if they're countable. Now, countable just simply means that there are individual things, and you can have something, by the way, which is called infinitely countable. So you still have an infinite number of objects, but they are countable. The example I've got here is the number of times a dice is rolled before a 6 occurs. Now, they're going to be discrete values because it's not like you can roll a dice half a time or something like that. So there are gaps between all of the outcomes. That would be discrete. So let's look at this one. The coin is tossed 3 times, and we're going to define our random variable capital X, the number of heads that are thrown. That would be our sample space, all the possibilities we could have got if we listed them in order. So head, 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 tail, and so on. So the sample space of X would be this. I suppose technically it's just 3, 2, 1 and 0. I suppose I've put those numbers in there to highlight that the first one would have an answer of 3, the second one has an answer of 2 and so on. We could draw up a table like this. This is our probability distribution table, and it's simply all the possible outcomes and then the probability of those outcomes happening, because that's what we're saying here. The probability that the random variable is equal to X. So one is talking about the event, one's talking about the probability that it happens. We could plot them on a diagram, so a graph of the probability distribution. It's not a very interesting graph, but it would look something like that. So the properties of this function, well, what we know is we have to get positive numbers. You don't get negative probabilities. And in fact, we know all of the probabilities must add up to 1, because all the possible outcomes would have a probability of 1. Now, if all of those probabilities are the same for every single X, so equally likely, then we say, well, that's a uniform distribution. It's perfectly uniform. And that will do us for today.